my privilege and honor to introduce Dr. Arunabha Ghosh, who is this evening's speaker. He is the founder, CEO of an organization called CEEW, the Council on Energy, Environment and Water. CEEW is globally renowned as a leading think tank on climate. Dr. Ghosh is a public policy professional with a vast experience. He did his PhD from the University of Oxford. He has worked at Princeton, Oxford, UNDP, and WTO. In 2018, the UN Secretary General nominated him to the UN's Committee for Development Policy. In 2020, the Government of India appointed him co-chair of the Energy, Environment and Climate Change track for India's Science, Technology and Innovation Policy, STIP 2020. He is the co-chair of the World Economic Forum's Global Future Council on Clean Air. Dr. Ghosh has advised India's Prime Minister's office, several ministries, state governments, and international organizations on a wide range of subjects. He was invited by the government of France to advise on the COP21, the COP26 just ended, COP21 climate negotiations. He has published widely and writes regularly on various issues of public interest in newspapers and magazines. He has featured in National Geographic and Discovery Channel. He has also delivered a talk on a TED Talk on air quality. Today, he speaks to us on energy transition to energy revolution, India's journey to energy security. Thank you, Dr. Ghosh, for accepting our invitation, and we look forward to your lecture.
Thank you, Professor Majumdar. It is a great honor for me to be addressing the annual meeting of Fellows of the Indian Academy of Sciences. I am not a natural scientist myself, so it is particularly a privilege for me as a social scientist to address all of you on an issue I believe is not just important for academics like all of us here, but for India's future. And I mean this without any exaggeration, because I believe the choices we make on our energy future will also determine our development prospects. It will determine how we educate ourselves, how we build our public health infrastructure, how we build our hard physical infrastructure, what kind of industries we build, what kind of economic sectors we promote, and even the kind of governance that we have, not just for running the energy sector, but in fact running our lives. So the title of my talk today is From Energy Transition to Energy Revolution, India's Journey to Energy Security. The reason I've given this title is because I believe as academics, our thinking and not just evolves over time, but we must constantly upgrade and update our own understanding of a very fluid situation as it is evident in our energy sector. 5 years ago, I wrote a book called Energizing India, along with colleagues in CEEW and in other institutions. And at that time, I put forward the proposition that we were going through 4 different energy transitions, and I'll talk about that during this lecture. But 5 years hence, I believe that we are now entering a period of energy revolution. What is a transition versus what is a revolution? A transition takes us from one point, one status, to another status. And of course, we expect that the second status is better than the first. But an energy revolution is one where not just that the transition happens, but we actually begin to question some of the core paradigms upon which we are going through those transitions. We start having to ask ourselves whether those core paradigms still apply. For instance, is the energy sector going to be large or distributed, or centralized versus distributed? Is the energy sector going to be determined primarily by liquid hydrocarbons, or by electrons? Is the energy sector going to be governed with institutions that have governed it for the past century or more? Or will we need very different institutions nationally and internationally? Will concerns of energy security be about the same issues, or will we have completely new issues on which we will have to reflect? Once we start questioning those core paradigms, I believe at least, that we will be entering a period of energy revolution. But this revolution is not going to be smooth. It will be disruptive, but it can be fashioned. Either we accept this revolution as subjects, or rather objects of an evolving energy landscape all around us, within and outside India, or we shape it as subjects in a manner that we are able to determine the new roles for technology, the innovative role of finance, the changes that we will need in policy and regulation, and of course, the fundamental transformation we will need in our behavior. So I hope to present these themes to you during the course of this lecture. And of course, I look forward to the questions that will come after. I will request my colleague, Nandini Hariwar, who has also helped me extensively in putting together this lecture, to kindly share the slides, as I have some technical difficulties at my end. The Council on Energy, Environment and Water that I represent is among Asia's leading policy research institutions. We founded it 11 years ago, and the kind introduction from Professor Mojumdar has already outlined that we have had an extensive role in shaping global and national policy. We work across the here and now issues of energy access, or building out or helping to build out the large renewable energy capacity that we can see in India, but also dealing with legacy issues associated with the power sector. But we also look at the medium and the very long term, where we consider low carbon pathways, including on issues such as net zero, about which I'm sure many of you have read in the newspapers in recent weeks and months, about industrial sustainability, but also pairing that analysis with our analysis on risks and adaptation to a very rapidly changing climate, looking at evolving technologies, and looking at the financial flows and the instruments that will be needed to drive the energy revolution, as I put it forward. So CEEW uses data, integrated analysis, and strategic outreach to explain and change the use, reuse, and misuse of resources. Let me start with a non-energy issue. Let me start with the bigger context within which we are having this conversation. Today, the negotiations for COP26 are still not completely over, even though they were meant to end yesterday. And I speak to you myself from the United Kingdom, where I've spent the last 2 weeks advising various governments on the evolving negotiations. The bigger context is that we are doing things to the planet that we have that has been going on for more than 2 centuries. But what we do to the planet is not nearly as bad as what the planet will then do to us in terms of a changing climate. Let us consider what has happened just this year. We have had, of course, been reading from the COVID-19 pandemic, a super shock to the entire global system. But at the same time, we've also faced significant disasters, whether it's Cyclone Tokte in Maharashtra and Gujarat, forest fires that were evident in Canada, Greece, Italy, even Siberia, Cyclone Yas in West Bengal, the severe cyclones in Germany and the floods in Germany and Belgium, the floods in Henan in China, which killed hundreds, and of course, severe heat waves across the northern hemisphere. And this is just what we have witnessed in the past 11 months. But what we see is that this is a growing pattern of what is going on across the world. Across the world, we see that most of the climate vulnerable regions are in the developing world. For instance, in 2019, Mozambique, Zimbabwe in Africa, and the Bahamas in the Caribbean were among the most climate affected countries, followed by Japan, Malawi, Afghanistan, India, with cyclones and floods causing severe damages. All this is happening against the backdrop that the Earth has already on track to warming 2.7 degrees. It has already warmed 1.09 degrees above pre-industrial levels, and it is on track to warming 2.7 degrees of above pre-industrial levels. The latest submissions to the UNFCCC process, the UN Framework Convention on Climate Change, suggests that it is possible that in the best case scenario, we might be able to bend the emissions curves and bring it down to about 1.8 degrees of warming above pre-industrial levels. But that is a very, very optimistic assessment. With just 1.1 degree of warming, we are already in a situation that over the past 2 decades, China and India accounted for 70% of all disaster affected people. Nearly 80% of people affected by storms were in Asia, with East Asia particularly being among the highest affected regions. And more than a fifth of the disasters in South Asia reported severe economic losses. India alone has had upwards of $80 billion of losses over the last 2 decades. What we also see is that as we think about extreme weather events, the intensity and the frequency of these events is becoming much more severe. At CEEW, we are developing the first high-resolution climate risk atlas for India, which we believe will be the first of its kind in the developing world. Normally, climate models look at India as a large region, and then you do the modeling. So to understand climate risks at a granular level, you have to downscale the models and pair the history of exposure to natural disasters with the climatological analysis that impacts the future. What we already know is that 3/4 of India's districts are now hotspots for extreme weather events like floods, cyclones, and droughts. 5 out of 20 Indians are highly vulnerable to all these three extremes. But at least 8 out of 10 Indians, 80% of the population, is living in districts that are vulnerable to these extreme hydromet disasters. What does this vulnerability mean? It means that those who are exposed to the natural event, you pair it with the sensitivity of those communities to those events, and you pair it again with the administrative capacity at a district level in order to see what is the resilience of that community or that administration to respond to these severe shocks. What we witness is that there has been a 12x increase in the associated cyclonic events over the past 50 years. And what is particularly worrying, and if you see the graph on the right-hand side, especially along our coast, you see 40% of India's districts are experiencing swapping trends, which means traditionally flood-prone districts are also beginning to demonstrate conditions of drought and vice versa. So how do you prepare for a future which is very different from the past? And until and unless we build up that resilience at the community and at the administrative level, these super shocks, a combination of floods, droughts, cyclones, pandemics, or public health challenges, etc., will continue to overwhelm our administrative capacities and our fiscal balances. As we think about these extreme events, it is also important to have the lens of equity. Not everyone's vulnerability looks the same. Consider the photograph on the top right of the slide. Clearly, it is a private jet. But that photograph is from the Chennai floods about 5 years ago. Now, someone who can own a private jet can also afford the insurance on that. Now consider the photograph on the left-hand side, top left. It's a coastal city. And as our cities get more built, as our economy gets richer, we will have more hard infrastructure that will have to be not just be able to withstand extreme climate events, but we will also have to face the prospects of severe economic damages. Now consider the fisherman in the bottom panel with a small fishing boat destroyed by a storm surge. The fisherman is also a citizen of India. The fisherman might not have the resources to insure against extreme events. So not everyone's vulnerability looks the same, even when exposed to very similar natural outcomes. So when we consider all of these issues of what we are doing to the planet in terms of how much greenhouse gases we pumped into the atmosphere, the way the planet is changing with regards to levels of temperature rise, and how the planet is beginning to impact us already at 1.1 degrees of warming, with far worse prospects for the future. How and why is this linked to energy? It is linked to energy because until we change our energy systems, we will not be able to create an economy that is resilient against those climate shocks. So, as I was saying right at the outset, India, I believe, is going through 4 energy transitions. The first is the shift from traditional to modern energy. Even just 6 years ago, when the Sustainable Development Goals were finalized at the United Nations, India had the unenviable title of having the largest number of people without access to electricity or to clean cooking energy. But over time, we will go through that transition of giving access to modern energy in the first place to millions of citizens. And I'll talk about that in a few minutes. The second energy transition is a shift from patterns of demand for energy in rural areas to urban areas as the population moves more and more into urban areas. And that will change, therefore, the kinds of energy sources we use and the kinds of energy business models we pursue in delivering those energy services for a much larger urban population. The third transition is going to be India's deeper integration into global energy markets. Of course, we all wonder about the fact that we are importing 80% or more of our fossil fuel requirement. So we must already be exposed to global energy markets. But our footprint as an economy in global energy markets is still marginal compared to North America or in the Far East. As we develop, that situation will change. So it is not about how much we are importing. It is more about what is the share of global energy that we will begin to impact by virtue of our decisions. And that will be affected not just by the import or not of hydrocarbons, but also the new energy technologies of future, whether it is renewables, whether it is battery systems, the critical minerals that will go into it, and our rising energy demand will begin to shape global energy markets. And the fourth transition that India will have to go through is this need to have a sustainable growth model, because we will not have the luxury of growing first and cleaning up later. These 4 energy transitions will not be occurring in a linear fashion, but they will happen. Some will begin to happen, some have begun to happen already, some will happen with greater intensity in the coming decades, but they will keep overlapping one after the other. And we will be looking at a situation where our energy future in 2047, when we are a 100-year-old country, will look substantially different from the kind of energy system we have today. So let me start by first talking about a little bit about how we've been progressing on ending energy poverty or moving from that first transition from traditional to modern sources of energy. At CEEW, we conduct the world's largest surveys on energy access by focusing on what we call a multidimensional definition of access to energy, which is not just measuring whether you have a connection to an electricity wire or to an LPG cylinder, but also looking at how many hours of supply you're getting, at what voltage the household is getting the power, how many blackout days it is experiencing, how many times the cylinder is getting refilled, how far is the refilling station for the LPG cylinder, how much it is costing, is the connection legal or illegal. Once you start looking at it in a multidimensional way, we have managed to look at the six most energy deprived states in the country and divide them up into various tiers of energy access, with tier zero right at the bottom and tier three approaching significantly improved access to energy. The good news is that about 118 million people moved out of absolute electricity poverty in just 3 years when we had conducted the survey in 2015 and then repeated it in 2018 by virtue of this big push towards electrification, not just of every village, but of nearly every household. And our estimation is that now about 97.6% of households are at least connected to a wire. Also, what you see on the right-hand side is that the number of households that are graduating out of tier zero, the very bottom part of electricity access, has improved. So what was 63% in 2015 is now fell down to about less than 40% in 2018. So bulk of the households are now in the tier one and tier two category, whereas the topmost category also has experienced an improvement. Now, while that connection has improved, there are still many other challenges that remain for those at the bottom of those tiers. The main challenge that now remains is the reliability of supply, as the panel on the left shows, and the quality of the supply, the number of hours you're getting, and the voltage, the non-fluctuating voltage at which you're receiving the electricity. Now we have to solve for those problems. As we move to a higher tier, there are other challenges. Reliability continues to be a major concern, but also affordability. And that is why it is important not just to connect the wire to the household, but also to understand whether the household has the capability to be able to pay for the repeated usage of electricity services month after month after month. One innovation that we definitely saw over the past several years, which particularly had an impact on access to electricity, is what India did with regards to the LED light bulbs, where the market grew 130 times, with now nearly sales of more than 670 million light bulbs by 2018, and dropped in the prices from what was more than 400 rupees per light bulb to less than 60 to 70 rupees. Now, this has, of course, had a major impact on the savings in energy, the 47 billion units of electricity that have been saved, the 20,000 crore nearly of cost savings that have accrued, and of course the 38 million tons of CO2 reduction that we now observe every year. So now there is the agenda that the Energy Services and Energy Efficiency Services Limited now intends to invest another $1 billion within the next few years to retrofit nearly 30 million LED streetlights. This shows that a combination of innovative public policy of government procurement and then selling the product down to the last mile consumer in installments can actually rapidly shift households, not just from lack of access to access, but also the use of more efficient appliances. We will now have to do similar things when we think about cooling demand in India, which is going to grow eightfold over the next 2 decades. This country will have the fastest growth in cooling demand, with residential cooling demand growing 11-fold over the next 2 decades. So, can we mass procure efficient fans, improve the efficiency of air conditioner, etc., as we move forward? The other big jump in energy access has been in cooking energy. And while across the world there are still well over a billion people, near 2 billion people still using traditional biomass for cooking, in India, the number has jumped significantly to more than 80% of the households. So, our estimation is that uh, about 71% of households are now using LPG as their primary cooking fuel. This is based on our latest India Residential Energy Survey, which we conducted in 2020, which is again the largest of its kind in the world. One of the challenges, of course, is that as this access to LPG has increased with the subsidized connection to the cylinder, the refilling of this of their cylinders continues to be a challenge because of the access, because of the affordability constraints. So what we see is that in eastern and central India, there is still what is called fuel stacking. So even if you're connected to an LPG cylinder, you're still using a combination of LPG cylinder with traditional biomass in order to fulfill your cooking energy needs. And the households in rural India need to increase their cooking energy expenditure to transition exclusively to the use of LPG. And until that happens, we will continue to have a challenge of increasing connections and yet seeing indoor air pollution as being a major cause of deaths in the country as long as those traditional biomass sources of energy are used. The second energy transition, as I mentioned, will be of the shifting patterns from rural to urban demand. And again, in this transition, we are already beginning to see a lot of innovative business models that are emerging. Let's start with rural demand. Bulk of energy goes towards irrigation. And we have about 30 million irrigation pump sets in the country, which are a combination of primarily two-thirds being electricity driven, and the rest being diesel. But India also has the largest number of solar-based irrigation pumps deployed in the world, with a plan now to deploy 1.7 million irrigation pumps through the Kusum scheme, plus another million through other schemes and other innovative measures. Now, the potential is that 38% of our current immediate target of 175 gigawatts of renewable energy could be achieved just from shifting to solar irrigation pumps. And again, like with the LED light bulb story, have a major reduction in the CO2 emissions per year of about 32 million tons. Of course, it would also save more than 1 billion liters of diesel annually, which are if the diesel powered pumps were to shift to solar. And our estimation is that there is a potential of more than 500,000 job years, full-time equivalent job years that can be created for skilled and unskilled workers through the Kusum scheme. So moving to sustainable irrigation is going to be one kind of transition in the rural demand. The other change in rural energy demand will be how you use energy, not to light up homes, but to power up livelihoods. We have estimated at CEEW that across India there is more than a $50 billion opportunity to use distributed clean energy to power income generating activities. The examples in the pictures on your left hand side of the slide show that you could be using solar powered, energy efficient sugarcane juicers, paddle looms, milking units, refrigerators, charkhas, flour mills. And these are happening all across the country, as the examples show. Once we recognize that there is this huge unmet latent demand for energy for productive enterprises, we realize that we now need a very different business model. Why? Because as I was showing you, that the connections to an electricity wire does not guarantee that the household has the income available to pay for the repeated use of that electricity, because that is a consumptive part of the electricity story. But the productive part of the electricity story is if that same household, maybe even in the same premises, were using electricity for income generating activities. However, if the grid is not going to provide quality and reliable electricity, as we again pointed out, that is a major challenge for tier 0 and tier 1 households, then distributed energy has a very important role to play. So at CEEW, along with an institution called Wilgrow, which is the country's largest social enterprise incubator, we started a program called Powering Livelihoods, which is a $3 million initiative where we are supporting 6 startups working on using distributed energy in rural areas to power livelihoods. The aim of the program is to have at least 10,000 beneficiaries using clean energy powered livelihood solutions, with more than a third of those beneficiaries being women, and at least demonstrate that there can be a 20% increase in the incomes of these households by using these more energy efficient and clean powered solutions. What we have witnessed already in the past year, and remember that the past year has been very challenging given the pandemic, is that the program has already impacted more than 4,700 households. So it's a 3-year program, but within 1 year, nearly half of those intended beneficiaries have been reached. More than 4,000 clean energy solutions have been deployed. And the whole point about this is that while 84%, rather than the target of 37.75%, 84% of the beneficiaries have been women. It is particularly exciting that now commercial investors are looking at this opportunity, because our objective here was to demonstrate the proof of concept that if a startup has been able to cross the technology valley of death, can we help it cross the commercial valley of death? And once you're able to do that, once you're able to go from, say, 7 lakh rupees of sales to 7 crore rupees of sales, maybe $1 million of sales, you're then attracting real commercial capital to help you scale up. This is just a small pot of the much larger economic opportunity that is there in driving rural livelihoods. And shifting from then rural to urban, we also see emerging business models even in urban areas. Because while urban areas are primarily connected to the grid, again, there are challenges of whether the service provision is good enough, and whether the costs can be brought down further, and whether we can reduce the losses that the distribution companies face. So again, what we did in collaboration with several distribution companies is design different business models for distributed energy that is connected to the grid for different segments of the urban population. One business model was what we call for the roofless. The other business model was for the creditless, those who have no credit history, are living in lower income areas in urban settings. And another business model which brings in the entire community. Now, how do these different business models work? In the case of the roofless, those who don't have their own roof but living in, say, apartment blocks, we have designed business models where you have community solar, where there's subscription fees paid by all the residents to draw on distributed energy for the common area consumption and other consumption, and the subscription fee is added to the bill, And then the community solar model saves the resident welfare associations between 35 to 55% of their common load electricity bill, which then translates into the individual residents' electricity bill. The distribution company benefits from the fact that its losses come down, and it has it is still catering to a population that is continuing to provide the resources and pay the bills. As we look at these different business models, we also begin to see that there is going to be emerging business models for energy use for mobility transition. In India's case, we conducted a countrywide survey of how India moves, and we see that more than 60% of Indian population still is actually walking. Its primary mode of transport has two legs, and then two-wheelers and three-wheelers dominate. But when you look at men versus women, the challenges of using public transport vary from quality of infrastructure being a major challenge for women to frequency of service and the safety and reliability and so forth. The electric mobility transition, along with the public transport transition, can greatly drive a transformation in the energy use in urban settings. We notice that we can have annual savings of nearly 10,000 rupees by shifting to an electric two-wheeler. For cars, the CO2 emissions could drop by 25%, depending on how much of that electricity is coming from renewables. But for the economy as a whole, we begin to notice significant gains where high indigenization, manufacturing of those buses and batteries, etc., in India can actually help us increase our automobile sector industrial value addition during this decade by more than 5% compared to a business as usual scenario, while we save more than 90,000 crore or rather more than 1 lakh crore in the reduced import of petroleum and so forth. Of course, there will be job losses in the existing automobile sector, and there will be job gains in an emerging electric vehicle sector. And the skills that will be used in both will not be exactly the same. But once again, we see that a combination of industrial policy, transport policy, and energy policy can begin to change very, very much the pattern of energy demand in urban areas. The third energy transition is India moving to the deeper integration into global energy markets. And as I said, India's role in energy markets will be like Europe's role in energy markets in the latter half of the last century, where we are not the largest demander of energy, but we are the most important swing player, which is why we have to think about not just the demand for hydrocarbons, but how will India's demand for renewables, etc., begin to impact supply chains, access to minerals, and so forth. India has also promoted the International Solar Alliance, which is now an international organization of nearly 100 countries, which is trying to aggregate demand so that the prices of all of these technologies can keep coming down, the cost of finance can keep coming down, while we keep deploying the energy systems of the future in the very regions where the sun shines the most. That then brings me to the final bit of my lecture, and I'll take maybe another 5-7 minutes before I conclude. We have to shift from growth to sustainable growth. And that has to happen because it's in our own interest, because of the changing climate, what the planet will do to us, but also the opportunities that arise. We notice that India has, of course, while its energy use continues to grow and its greenhouse gas emissions continue to grow, its energy intensity and of GDP has actually come down, and its emissions intensity of GDP has come down by about 24% since 2005 against the 33% that was the target for 2030. And in some ways, the India's performance is doing better than that of some of the larger economies such as the United States or Japan or Russia. So while this energy and emission intensity is coming down, we still have to think about how do you bend the emissions curve while increasing the energy infrastructure. Of course, we could complain in India that why should we bend the emissions curve? Why can't we continue to consume fossil fuels? We have not created the problem. And in some ways, the issue of equity and climate justice cannot be ignored. The analysis that we did at CEEW showed that industrialized countries as a whole reduced their emissions only by 3.7% between 1990 and 2019, against a much larger commitment or expectation we had for them. In fact, they've consumed, as the number shows at the bottom, 25 billion tons of carbon dioxide equivalent, more than what they had committed to or they had been allocated in terms of emissions allowances just since 2008. That is half the world's annual emissions. Even if you look forward, as the number at the bottom right shows, countries such as China, US, and the European Union can free up more than 113 or nearly 114 gigatons of carbon dioxide if they shifted their net zero years by 10 years. So China moves from 2060 to 2050 and US and EU move from 2050 to 2040. This extra carbon space, when the world's carbon space has shrunk severely, will be necessary for developing countries like India to be able to move to a sustainable pathway, even while taking some time to move to this transition to a low carbon future. And it is against that backdrop of balancing the need for energy demand, those transitions that are going on, the climate risk that India is going to face, making sure that this is a just and equitable transition, that India's recent commitments should be kept in mind. Already, India's solar power capacity has grown 17x in the last 7 years. $70 billion of investments have come. But going forward, we need at least $160 billion of debt for renewables. We need another $200 billion for electric mobility. We need another $200 billion for green hydrogen. We need maybe $100 billion or more for upgrading our grid. And this is all in the coming decade. So the commitments from India that were made on the 1st of November are fundamentally important to understand this now shift from energy transition to energy revolution, where now we are looking at building out more fossil capacity than the entire electricity system. We're looking to reduce emissions in absolute terms by 1 billion tons over the course of this decade, and so forth. And in September this year, India submitted 20 out of 200 energy compacts to the United Nations. So 1/10 of all the energy compacts that came to the UN for the high-level dialogue on energy came from India, which includes provisions of a universal energy access, the massive rollout of renewable energy capacity, the National Hydrogen Energy Mission that was announced in August, the schemes to increase production of solar capacity, manufacturing capacity in the country, and so forth. And as I was saying, we have also been promoting international institutions such as the International Solar Alliance, the Coalition for Disaster Resilient Infrastructure, and created new platforms like the Clean Energy Access Network, or engaging with international technology collaboration platforms such as Mission Innovation. Now, this is where things get revolutionary, because as we model out the net zero scenarios for India, we see that there is going to be a complete change in the way the electricity sector and other sectors will evolve. We plotted out more than 16 scenarios for different net zero years, 2050, 60, 70, 80, on like that. And we also have looked at high hydrogen scenarios, high CCS scenarios, low hydrogen, low CCS, and so forth. Broadly, if you see, there is this massive increase in electricity generation across scenarios as we approach our net zero year. There is also a massive increase in solar capacity, which approaches about 5,600 gigawatts of solar with hydrogen, and without hydrogen, it jumps to 7,500. Without hydrogen and without CCS, it jumps to 7,500 gigawatts of solar by 2070. Coal has to come down to nearly zero, and the role of nuclear will also be important, rising up to between 200 and 400, depending on the scenario, as we look towards the end of the century. The same begins to apply in many other sectors. In the transport sector, we see a more than 85% of the vehicles will have to be electric. The rest will be hydrogen-powered long-distance trucks. The share of electricity in the industrial sector has to jump from less than 20% today to over 70%. The rest will have to be taken up by hydrogen, which will account for, or particularly green hydrogen, which will account for about 20%. So we are looking at a completely different way of using fuels, of manufacturing fuels, of transporting fuels, and of course the end use of those energy sources. And as we consider then those new fuels, we see that there is opportunity. That map on the bottom shows that it's within the tropics where the sun shines the most, where you also have the potential to have the lowest cost production of green hydrogen. By our count, at least 32 countries plus the European Union already have hydrogen programs. At least 24 of them are focused on green hydrogen. Now, can we, as we look at our 5 to 6 million tons of hydrogen demand currently, start thinking about the move towards green hydrogen, whether it's used in refineries, whether it's used for fertilizer, whether it is used for steel? The global demand for green hydrogen, or rather hydrogen itself, will jump from about 90 million tons per annum to about 530 million tons during the latter half of the century. And that then will require most of it to come from renewable derived hydrogen. So can India then become a production and export hub of this critical industrial fuel of the 21st century? Let's move on. So at CEEW, again, we mapped out and plotted out whether that's possible to replace green hydrogen or rather substitute green hydrogen in place of coal in the blast furnace for manufacturing of steel. And we see that we can move towards a blending of between 9 and 17% of green hydrogen immediately into the fuel mix in order to lower the emissions that come from the steel manufacturing, and also increase the volumes that will potentially bring down the prices. We believe that by the late 2030s, 2040, green hydrogen-based steel will become commercially viable for India, maybe even earlier, but it will require thinking about the resource allocation, etc., in terms of how much solar will be needed to produce that hydrogen, the land area that will be needed, the investment that will be needed, the water supply that will be needed, just to be able to manufacture, say, the 100 million tons of steel that we currently make into green steel. So constantly there has to be a evolution of not just the fuel, but a much more systemic approach towards other resources, land, water, finance, while we tap into an emerging technological field. The other challenge that will emerge is that our concern about security, energy security, will shift from that about securing hydrocarbons to securing minerals. Again, at CEEW, we had developed a mapping of critical minerals. We analyzed 49 critical minerals that were important for our industrial development and found that many of them, as you can see, particularly the top right quadrant, where the minerals have high economic importance for our industrial development and also high supply risk because they're coming from, say, politically sensitive regions in other parts of the world. And you can see a move towards electric mobility, which shift many minerals into that zone one of high economic and supply risk importance. And therefore, recycling of the minerals and securing those minerals from within the country will be critical. Next slide, please. Because the geopolitics around critical mineral supply will be particularly challenging. We can see that there is that between 2015 and 2060, demand for materials for electric vehicles will grow manyfold. For batteries, it will grow 87,000%. For wind power and solar cells, 1,000% and 3,000% growth. Now, all these critical minerals come from just a few parts of the world where we will need to establish clear trade relationships, or as I said earlier, we'll have to rely on our own domestic recycling of e-waste and so forth to be able to improve our security of supply. And the final thing that we will have to secure is the funding for all of this. Already we see that the bulk of the energy investment does not go to where the sun shines the most. Most of energy investment is still concentrated in North America and in Europe, whether it's green bond issuances, whether it's direct equity investments. And we see the top right quadrant, we see that the cost of finance is the highest share in our otherwise fairly low renewable energy costing. So we have to then bring down the costs of finance by de-risking investments in this rapidly changing energy scenario in India. Which brings me back to where we started, the climate crisis and the negotiations that are underway. As we think about climate negotiations, as we think about domestic energy policy, as we think about our own targets for net zero, for renewables, for electric mobility, for industrialization, what is the end game? The end game is that we have to become a climate resilient economy that is able to withstand those climate shocks. But we also have to continue to become a domestically and globally competitive economy where the industries of the future are the ones where we have growing competitiveness. That means we have to tap into technologies of the future, such as green hydrogen. We have to ensure that money flows to where we need it, not at the $10, $11 billion a year, but at the 30, 40, 50, maybe $100 billion a year of investment that we'll need in green infrastructure. Of making sure that the energy transition is closer to people, to rural areas, of tapping into those hundreds of billions of dollars of opportunity over the coming decades, but also while making that energy infrastructure resilient against climate risks. So let me conclude then, not with energy transition, but some maxims for energy revolution. Maxim number one is that energy security, which every nation aspires for, is not the same as energy independence. We will, as I've shown you, have a transformation in our energy system, but we'll also have to rely on resilient supply chains globally, whether it's for minerals, whether it's for batteries, whether it's for components. And we will have to ensure energy security is enhanced while building synergy with other countries. Similarly, indigenization of energy sources, whether it is manufacture of batteries, of electrolyzers for hydrogen, whether it is manufacture of electric vehicles, is not the same as protectionism, because we will need foreign direct investment, we will need reduced trade barriers, we will need access to global markets. And that is why, again, those integrated supply chains will be critical so that we can secure resources we need while we can also supply resources others need. And finally, the maxim is that the energy transitions that I talked about is not the same as an energy leapfrog. And India now is at an inflection point when it is demonstrating those four energy transitions already, from traditional to modern energy, from rural to urban, deeper integration to global markets, and looking at sustainable growth. But it can make a bigger leap of going through or bypassing the traditional energy sectors into a very different energy future. That is what the net zero announcement should be considered against. That is what we believe should be a case for economic transformation, not just energy transformation.
Thank you very much, Dr. Ghosh. That was a stunning talk and lots of information, scary details, and the preparations that all of you are advising the government and us today. Thank you very much. This was really wonderful. It might be of interest to you that in the morning, we had a very similar session where there were 4 speakers who were talking about electrochemical ways of producing energy and possibilities of their sustainability. So we heard a lot about green hydrogen that you also have talked about. So this is interesting that today a lot of discussion was held on energy. There are some questions on the chat box. One question is from me, but I'll ask that at the end. One question is from Professor Rene Borges, who is one of the secretaries of the Academy. She asks, is India serious about ethanol-fueled cars? What is the environmental cost of this? And she also had asked another question, how green is renewable energy? What is the environmental cost of solar energy in terms of production of solar panels and the cost of the minerals required to manufacture them?
Well, both are very important questions. On the ethanol blending, there is this there is the target that we have put forward under the Energy Compact submitted to the UN, which is of 25% blending. 15% blending by 2025, and 15 million tons of ethanol being produced. Now, as this evolves, at least our modeling is based on the best understanding of current technology and the technology patterns. We see that the net zero transition will primarily, in the transport sector, will primarily be focused on electric, because the costs of batteries, etc., will drop in a way where at least traditional biofuels will not be able to compete. Synthetic biofuels, third generation biofuels will have a role, but it will depend on what kind of policy clarity is given to encourage that R&D, but it will still primarily go towards perhaps long distance transport, that or the hydrogen, which then raises or further complicates the question that has been asked about the environmental footprint, and which is why the recycling of panels, etc., has to become a very important part of our manufacturing of renewable energy products. Our estimation is that 44% of our current critical minerals demand can be met from e-waste recycling. So rather than digging up more of this from, whether domestic sources or from international sources, reducing or creating a circular economy of minerals has to become, in my opinion, a clear policy for India's energy transition. Otherwise, we will, as I said towards the end of my talk, end up with a very new set of energy security concerns and, of course, the environmental concerns. The same, although it was not mentioned in the question, but the same will apply even for green hydrogen, where unless we are able to make sure that we are not severely impacting our water constraints in producing green hydrogen, we will again face up against a different type of an environmental challenge. So moving only to clean energy does not mean that the supply chain is automatically cleaned up, and that will require very clear guidelines and policy and regulations for oversight.
There's another question from Professor Deepak Pental, and he's asking, is it only a game of mobilizing financial resources, or is there a need of R&D in India alone or in collaboration? What are the policy changes in manufacturing?
Again, an outstanding question, because this is why the current and the future have to go hand in hand. If you look at technologies that are already available, it is primarily a game of financing. We are receiving about $10 to $11 billion a year in investment, domestic and international, for the renewable energy deployment that is going on. However, we need between $30 to $40 billion a year for our for our renewed renewable energy targets. We need about $20 billion a year for electric mobility. We need about $20 billion a year for green hydrogen. Now, this investment is not going to come only from domestic sources. To just give one number, put it all in perspective, our banking sector's exposure to the power sector today is $160 billion. So all loans given to all types of power assets is $160 billion. And we are saying that within the next decade, just renewable energy capacity, not even grids, will require another $200 billion. So we will need that. We simply do not have the depth in our debt markets in India to be able to finance this kind of a transition from domestic sources alone. But then comes the R&D part. Green hydrogen today is $4.50 a kilogram. We need to bring it down to less than $1 a kilogram. That is not going to come just from international investment. It has to come from R&D, and where collaboration is needed. I have proposed recently a global green hydrogen alliance where countries are able to pool their technical and financial resources to create those R&D platforms to drive down the costs of electrolyzers, to find alternative materials for the membranes in those electrolyzers, to find alternative ways of safely storing and safely transporting the green hydrogen. And all this will require international cooperation as well. As a co-chair of the energy track of the Science, Technology, Innovation Policy, I had proposed such platforms not just for hydrogen, but also for other transformational technologies, including for more efficient solar panels, for even carbon dioxide removal. Now, in terms of manufacturing, there is something called the Performance-Linked Incentive Scheme, where the target is to build out capacity of 10 gigawatts of manufacturing within this decade of solar panels and modules. But I think the manufacturing story will have to be much wider than that, which includes battery manufacturing, for which there are PLI schemes, but also, as I said, incentives have to be given for recycling of those minerals. Incentives have to be given for manufacturing of electrolyzers. Incentives have to be given for indigenization of the powertrains and the batteries for electric vehicles. So it's a combination of finance for technologies of the future, pooled funds for developing technologies of the finance for technologies of today, pooled funds for developing technologies of the future, and incentives for building out the manufacturing base in line with this rapidly rising and changing energy demand.
Dr. Ghosh, before we stop, I have one question, which I had asked in the chat box, so I'll just read it out anyway. We hear that in the past, almost all countries have slipped on their promises to cut down on emissions. What is the guarantee that they will be able to keep their commitments that they have made in Glasgow?
The short answer, this is perhaps the most important question, Professor Majumdar. The short answer is there is no guarantee. And this is unfortunately the challenge, the biggest constraint within which India has to develop and design its energy policy and its economic policy. Why? There is a carbon equation which says that there is just about 300 gigatons of carbon space left to have a chance of staying within 1.5 degrees. Despite their net zero commitments of US, China, EU, the latest carbon space analysis that CEEW has brought out this week shows that these three regions will consume 90% of the available carbon space for the world to stay within 1.5 degrees. 45% of that available carbon space will be consumed by 2030 alone. This is the best case scenario, Professor Majumdar, that even if these countries that have not met their promises in the past met their promises of moving to net zero, the way their policies have been lined out, they end up consuming 90% of the available carbon space. Now, what does India do? India still has to grow, it has to provide jobs, it has to grow its industries, but it has to do it within that rapidly shrinking carbon space, hence that fourth energy transition from growth to sustainable growth. But sustainable growth now cannot be a slow-moving dynamic, it has to be a revolutionary dynamic, which is why we have no other option but to start looking at these not just alternative energy technologies of today, but the foundational technologies of the future, and not miss the bus on them. So not go from importing oil to importing hydrogen, or importing oil to importing 5,600 gigawatts of solar panels. So this is why I say that this is a revolutionary change that we will have to engender, not just through a political speech or a policy statement in parliament, but where our students, academics, research institutions, companies will all have to completely rethink the kinds of investments they're making, the kinds of technologies they're developing, and along with that, the kinds of business and financial models they're evolving in order to accelerate the progress towards this different energy future.
Good. So we'll stop with this thought that you have left in us. And really, it was a very nice talk, very clear, simple language, and I certainly enjoyed listening to you. Thank you very much, Dr. Ghosh.
Thank you again for this opportunity, and we'd be happy to share the slides if you would like them for your membership. Once again, it was a real privilege. Thank you for having me.
Yeah, like I told you earlier, that I've taken your permission to record your entire speech. So, and that will be on the Academy's YouTube channel for our fellows and others to view. So, yeah, the slides are already with us in some ways. Thank you very much.
Thank you.
Have a good evening. Thank you.
Thank you.
Thank you.